Hello everyone, welcome to the series of Computer Organization and Advanced Microprocessors. This is our 8th lecture, and in this 8th lecture we will learn about the Boolean Algebra and their simplification rules. So as we know that in our last lecture we studied about the logic gates and how to draw the logic diagram or a digital circuit. So now we know that we have an expression to draw the logic diagram or a circuit, right? But that expression is quite big. So how to simplify that expression using the Boolean algebra rules or a simplification rules, that we will learn in this lecture. So let's start with it. Before we go to learn about the simplification rules, first we need to know that why we need to simplify the expression, right? Why we need to simplify the expression. So first we learn that why. So to understand this why, let's take one example. As you can see that here I have one example, one expression we have. The expression says ab whole bar, then a bar plus b, then b bar plus b. So if I ask to draw the circuit, how will you draw? So let's start the circuit first. So here I have two variables. So we will say a and b we have, and both have a negative values, both have a NOT gate. So a line is here, then we have a b line, then first we'll see, and both have a bar, so we'll take a NOT gate for both the variables. So this is my a bar, and not once this is my b bar. Okay, so now I have four variables a bar, b bar. Fine. Okay, so now first let's start with the first value, first thing, that is a b bar. So for that, let's take a, then take b, and a dot b. So dot means we have here AND gate. So AND gate we have, and whole bar means this, and again not. Not fine. Okay, so I got a b bar. So this first expression is done. Now let's take the second expression, that is a bar plus b. A bar plus b means here I need to take, this is my input lines. Okay, a bar plus b. So this is my a bar, then b, and plus operator is there, means here we have OR gate. Okay, so we got a bar plus b. Fine, so this is my second expression, and last we have b bar plus b. So let's draw this. We have b bar plus b, then b, and plus operator, so OR gate, and finally we got b bar plus b. Perfect, right? So after that we can see that here we have dot, then here we have dot. It means we need to draw the AND gate. So let's draw the AND gate for all these three inputs. So first we have first AND gate. So I got the first expression. Let's give the name to this. First, let's say I give F1, right? So I got the F1. F1 is connected with this. Let's say F2. This is my F2. This is my F2. And let's say this whole expression I call F. So I'll draw the AND gate, and finally I got F. So this is my output, right? It's easy. We know that how to draw the digital circuits. So now as we can see on the screen that after drawing the logic circuit for the given expression, how many total gates we have? 1, 2, 3, 4, 5 and 6 gates we have, and also we have number of buses along with the different lengths, right? So based on the number of gates and length of the buses, we calculate the cost of the circuit. Implementation cost, because of course we have drawn the circuit, means now we need to implement. So when we implement any circuit, we calculate the cost based on the components implemented on it. So of course it will cost more, we can see, right? Because many gates are there, length of the bus is quite big. So if I put it in a side, and if we see this, that after simplifying the expression, finally I got this, see, a bar only. So in that case, means after the simplification of the expression, if I ask to draw the circuit, how will I draw? I'll simply say A is my input, then I need a bar, so I'll simply say not gate, and I got a bar. Perfect. So now you can compare easily that having this quite large circuit and having this small circuit, of course it will reduce the cost and it will increase the cost, of course. And it is quite, and this is quite complicated, right? It is a complex structure, we can say, while it's a very easy. So as we can see that a complexity is high and cost is high, so of course we'll prefer one easy circuit along with the low cost, and so we need simplification rules, or we need to simplify the expression. Fine. Okay. Okay, so now seeing that what is the need to simplify the expression, let's see about the rules of the simplification rules for Boolean algebra. So very first see that what is Boolean algebra, any expression, yes, and here we need to know that there was one mathematician whose name was George Boolean, and in the year 1854 he introduced Boolean algebra to simplify the Boolean expression or any expression. And as we know that there are few factors like cost. Of course we know that more components, more cost. Then if more components are there, more power supply required, and if more components, then it requires more space. So these three factors are most important to simplify the any expression, which can reduce the cost, reduce the power, and reduce the space. So let's see about the rules. So here you have different rules. As we'll simplify different expressions, we'll understand that what is the significance of the particular rule. But you have to remember all these rules, like a plus 0 is equal to a, then a plus 1 is equal to 1. In all the rules, remember one thing, that this a value or this b value, any b or a value or a c value, this can be any value. Means if I say a plus 0, means my a can be anything. My a can be 1 or a can be 0. I don't know what would be the value, but at the end my output would be a only. So here few rules are there, and you need to remember all these rules, and of course you can validate all these rules with the truth table. Okay, so now let's take one example that how to simplify the expression. So here we have one example that this expression we have, and we'll simplify it, and at the end let's see that how we get this simplified expression. So our expression is a plus c, then ad plus ad bar, okay, then we have ad plus ad bar, then plus ac plus c. Okay, so this is our main expression or original expression. Now I'll simplify it. Okay, so how to simplify it? First, let's start the very first step. In the very first step, we will take this a common from the expression. So now let's see. Then what will be my expression? A plus c. Then take a common. That it will be d plus d plus d d plus d bar. Then rest of all will remain same, a plus c. Okay, so I got this. So okay, my this step is done. Fine. Now my second step. In second step, as you can see, the d plus d bar. Okay, so let's search for the rule d plus d bar. Okay, I got this. A plus a bar means the output would be 1. So instead of the d plus d bar, we'll put the 1. So let's write a plus c, a dot 1 plus ac plus c. Okay, now third step. For the third step, as we can see over here, a dot 1. So let's check for the rule that a dot 1. Okay, here it is. A dot 1 means output would be a. So my third step would be a plus c. My a dot 1 will be my a, then plus ac, then plus c. Okay, so now this step is been completed, right? We got this step. Now after this, fourth step. Okay, now as you can see that a is common in this and in this expression, so let's take it common. So a common from the both the expression. Now what will remain? A plus c will be there, and plus, and then c, and plus c. So after taking the a common, I'll get capital A, then a plus c, and plus c. So I got this step. I completed this step. Fine. Okay, now let's go for the fifth step. In the fifth step, what will we do? We'll simply write a in the bracket a plus c plus c. We are just taking out these variables from the bracket and plus c. Okay, so now we know that in the sixth step, what we will perform, that c plus c, that is my this step. See, fifth rule, a plus a is equal to a. So instead of the c plus c, I can simply write a plus c. That's it, right? So instead of this c plus c, I'll just write the c plus c. Easy? Okay, so see, this step done. Fine. Now seventh step. In the seventh step, what we are going to do, we are multiplying these variables with the bracket variables. So a dot a this, right, plus a dot c, then plus c. See, so this step we got. Now after that, next eighth step, my eighth step is a dot a. What is a dot a? Now let's check the rule. Seventh rule says a dot a is equal to a. Okay, so instead of a dot a, I can simply write a. And now from this expression, I'll take the c common. So plus c common, and what will remain? A plus 1. 1 or a t, anything you can write. So I got this step, right? Instead of the 1, I can also write the t. And after that, now see, a plus 1, this a plus 1. So where is a plus 1? This second rule, a plus 1 is equal to 1. Okay, so my ninth step, a plus c, and instead of a plus 1, what I can write? Simply 1 I can write. Okay, so and the last step, that is my 10th step, would be a plus c. So a plus c dot 1. Now let's see c dot 1. So c dot 1 means my dot this fourth rule, right? My fourth rule, a dot 1 is equal to a. So c dot 1 will be my c. So finally I got a plus c, and this is my simplified expression, we can say. So as you can see that on each and every step you need to apply some mathematical rule, some mathematics, and also sometimes you need to apply this Boolean algebra, this simplification rules for the Boolean algebra. Okay. Okay, so now you know that how to simplify the expression from the video. Now you have to do it by your own, applying the different rules. So here some examples, some activities for you. Just simplify the expressions and check your output. This example we have already seen in the video, so but try it by yourself. Also try this example, and after simplifying the expression, also check for the truth table values, that does your truth table validate the expression or not. Okay guys, so it was all about the Boolean algebra and simplification rules, that how to apply the different simplification rules on expressions to reduce its complexity and to make it more simpler. So keep learning, happy learning, and thank you.